Alright, Mr. Claxon's algebra students, what I'm going to review very quickly is how to graph linear equations that are in y equals mx plus b form. There are some of you, that's not what I want. I don't want it that big. There are some of you that might need just a little refresher here. Obviously, you can pause and read all the steps. I'm going to tell you the steps as I say them. The first thing that we need to do, solve the equation for y. That's already been finished for us. In a previous video, we discussed how to solve for y. Next thing that we need to do is outline, label, and scale our axes. So that's what we're going to go ahead and do. I do want you to have a straight edge for this. If you're really good at freehanding a straight line, then you can freehand it. If not, get out your ID, get out some type of straight edge. We've outlined. Now we just need to label our axes. So let's go ahead and label. The x and y axis, the horizontal axis, is the x-axis. Then the vertical axis is the y-axis. Make sure you remember that. And now last, we're just going to scale. And the scale doesn't have to be anything overly complicated. 1, 2, 3, 4, 5. Nothing overly complicated to start. You might need to adjust the scale. You might need to go by 2s in order to fit your entire line on the graph. So there are times that you have to go back and erase if you do not consider how much space you need ahead of time. For this particular graph, I might need to grow it up just a little bit. But we can do that, not a big deal. So after we've outlined, labeled, and scaled our axes, we need to plot the y-intercept at that point 0b. Okay, the 0b comes from, and look at that, I was just smart enough to make that first y-intercept brown. 0b comes to us from y equals mx plus b. So in equation 1, b is -3. So down 3 on the y-axis, the y-intercept. Think about an interception, right? So we know this line intercepts the x-axis, or the y-axis rather, at -3. Go ahead and put a -3 there too, just to prove to yourself, oh yeah, that's -3 there. Sometimes you'll catch yourself making a mental mistake. I definitely want to avoid those at all costs, so go ahead and always put the value there. I now have 1 point on the line. All I need is another point. You know that 2 points make a straight line. So I'm going to follow the slope. Slope, we remember in high school algebra as change in y over change in x. The easiest way to write change in y over change in x is delta y over delta x. You will see that in calculus. So just a little preview. Delta y over delta x. So what is my change in y over my change in x? I write as a fraction as 2 over 1. And what that means is I'm going to be going up to right 1. In the same respect, I can come up with an equivalent fraction that's -2 over -1, which means I would be going down to left 1 from this point right here. I'm going to go ahead and select the blue. Okay, I'm going up to right 1. I have a point. And I can follow this up to right 1. I can follow this pattern for the entirety of the graph. I'm sure you know that. I could have also went up 6, right 3 if I wanted to, because 6 over 3 is the same as 2 over 1. And then I could also go down to left 1, down to left 1. And understand we are solving a system of equations. We want to try to be accurate. You must use a straight edge. I don't know a lot of students that can freehand that well, so go ahead and use a straight edge. Always extend your line. Okay, do not just take it to the last point and stop, and always make sure that there are end caps on your line. It's just good practice. It's good math practice there. We go to equation 2, the green equation, and what you see there is the Y-intercept in improper form. Some of you may go straight to your calculator and say 47 divided by 7, but you know what? You're smarter than a calculator. How many times does 7 go into 47? And if you were paying attention during class today, you said 6. It goes in 6 times. 7 times 6 is 42, with a remainder of 5. So that's my numerator, sevenths. And I just leave it at 5/7. I do not have to write it as a decimal. 6 and 5/7. Remember, I'm going up 6 and 5/7. I need to make one more tick mark. Actually, 2 more. Put a 7 there, and I will know, as long as you have it clearly written as 6 and 5/7, that that's really, really close. It's close, not really close, but it's close to 7. Close to 7. Now, my slope gets a little more tedious here. Change in y over change in x. My slope is -3/7. Now, the thing about that -3/7, some people forget this negative only goes with one of these, and I get to pick which one it goes with. I could leave it out in front, but that's not going to help me very much. It could go in the numerator, -3/7, -3 divided by 7, or it could go in the denominator, 3 over -7. We're going to go ahead and stick it in the numerator for now. So -3/7. Remember, rise over run, change in y, that's vertical change, over divided by horizontal change. So what that means is we're going down 3, right 7. Down 3, little abbreviation there, right 7. Not as easy to do because we do have a fraction here. So if I were to go down 3, down 3, right 7, I would be down 1, 2, 3, and you may see that as 3 and 5/7. You should notice 3 and 5/7. And then right 7. 1, 2, 3, 4, 5, 6, 7. So there's the other point. Understand, if I would have went up first, or if I would have chose up 3, left 7, that would have put me somewhat off the grid, and I would have had to rescale my axes. So this is, this is desirable. Let's go ahead and make that line. Make sure you're using a straight edge. Get that ID out. Hopefully you don't have a credit card. Boy, I hope not. Not already. Well, or maybe you're learning fiscal responsibility. That would be, good for you. But, try to put it as exact as you can. And always, always, always extend your line just a little bit. You can see the estimated point of intersection there. The estimated point of intersection is, I'll go ahead and mark it in red. Try to mark that in red. That's not what I wanted to do. I want to mark the intersection in red. I need to go up here and grab the pen. So I would like to mark that intersection in red. You know that intersection point is about 4, 5. So that's what we need to back substitute. How do we say it? Plug it in, plug it in. We need to back substitute that into both of these equations for our final check step. So check it out. Need you to check that. Plug it back into the blue equation. We're going to take 6 times 4 minus 3 times 5. And we're going to ask ourselves, is that equal to 9. What we end up getting is 24, looks like 29, 24 minus 15. And I think you probably know by now that that is equal to 9. We can leave it there. It is a true statement. We just proved it. And then, for the green equation, back to the original, 3 times 4, because that's the x value, minus 7 times 5. And you're asking yourself, is that equal to 47? Hopefully you're not going to that calculator. Well, actually that's not a minus, plus. See, I went back to the original. Oh yeah, I did not write that correctly. Back to the original. I see that needs to be plus. 12 plus 35. You are already thinking it. Yes, that is equal to 47. True and true. I know now that that's a solution, and I can state that it is a solution. So I know that this is my solution. It's no longer an estimate. I know it. Thank you very much for watching. Make sure you follow these directions when graphing that system of equations.